5 years might not sound like much, but in tech, those first years can completely transform you as a developer. The way you think, the way you write code, the way you work with other people, it all changes faster than you expect. So let's rewind to the very beginning, those first 2 years, the phase where everything feels fresh and exciting, but also, let's be real, a little bit overwhelming. Hello everybody, and welcome to the very first episode of the Tech Odyssey podcast. I'm your host, Mike, and together we're going to explore the vast universe of tech and everything that comes with it. Today, I want to take you on a journey through your first 5 years in tech. These are the lessons I wish someone had told me when I was just starting out. Lessons that would have saved me time, stress, and a lot of trial and error. Whether you're brand new or already a couple of years in, what we're going to cover today can make your path smoother, more intentional, and way more rewarding. And here's the thing, 5 years might not sound like much, but in tech, those first years can completely transform you as a developer. The way you think, the way you write code, the way you work with other people, it all changes faster than you expect. So let's rewind to the very beginning, those first 2 years, the phase where everything feels fresh and exciting, but also, let's be real, a little bit overwhelming. When you're just starting out, the tech world can feel endless. You've got Java, Python, algorithms, databases, and then, just when you start to get your footing, a new framework pops up and everybody's talking about it. But here's the thing, these core skills are your foundation. Just like an architect needs to know brick and steel before designing a skyscraper, you need to master programming basics before worrying about any fancy framework. So if you want to get your first few years right, invest your time in skills that actually last and stick with you no matter what new tool comes or goes. Alright, number one on the list is pick your main language and really know it inside out. If it's Java, for example, focus on object-oriented programming, data structures, exceptions, and collections. If it's Python, just get comfortable with scripting, automations, and data handling. Now, if it's JavaScript, don't just rush straight into frameworks like Angular or React. Learn the core language first. Understand things like the event loop, promises, async await, closures, and how the DOM works. Once you've got that down, picking up frameworks becomes way easier because you actually understand what's happening under the hood. Now I know what you're thinking. New frameworks keep popping up every month, like React, next month is Next.js, then Vue. It's tempting to chase them all, thinking that this is how you'll grow. But the truth is that frameworks change all the time. Fundamentals don't. So if you can design good algorithms, write clean code, and work with databases, you'll adapt to any framework. If you chase frameworks without building a foundation first, you'll always feel a step behind. So don't ignore frameworks, just think of them as tools. Tools change, but how you solve problems is what really lasts. Okay, so once you got your core language on a solid level, next up on the list is to level up with algorithms and databases. But why do these two things matter so much? Let's start with algorithms. Algorithms are basically recipes for solving problems efficiently. And no, they're not just homework problems or something you memorize for interviews. They actually show up in real-world projects all of the time. For example, imagine you have a list of 10,000 players and you need the top 3 scores. If you don't know anything about algorithms, you might loop through the list repeatedly, checking every score manually, which will work, but it will be very slow, messy, and it won't scale if you suddenly have 1 million players. With algorithm knowledge, you pick the right tool. Maybe sort the list once and grab the top 3 items, or use a mini heap to track the top scores as you go. Cleaner code, faster execution, and it scales with no effort. This is why learning algorithms is important. It teaches you how to solve problems efficiently and not just how to make something work. So what to focus on? Focus on sorting and searching algorithms like how to order data and find what you need quickly. Data structures like arrays, lists, sets, maps, trees, and graphs. Problem-solving patterns like recursion, greedy approaches, and dynamic programming. And let me make something clear. You don't need to memorize every algorithm. Just start with the basics, understand how they work, when to use them, and why they're better than just brute force. Now, let's go to the databases. Databases are important because this is where your app's data actually live. Every real-world app, whether it's a game, social network, or an online store, all these apps depend on databases. Think of a search in an e-commerce app where the user is looking for, let's say, blue sneakers. Without any database knowledge, you might just pull all the products into memory and filter them in code. It's fine for 100 items, but once you go to 100,000 items, it gets super slow. Now, if you know about databases, you will write an efficient query, use indexes, and let the database do the heavy lifting, which is fast, scalable, and professional. So, what to focus on when diving into databases? Make sure you know the SQL basics like read, write, and join tables, indexes, and query optimizations. Know why some queries are slow and how to fix them, and also learn about SQL basics. Understand the relational versus non-relational databases and when to use each. Bottom line, algorithms teaches you about how to solve problems efficiently, and database teaches you how to store and access data efficiently. Master both, and you'll be ready for almost any project that comes your way. Now that you've built a solid foundation with your language, algorithms, and databases, let's talk about something that's often overlooked, and that is writing code that other people can actually understand. Clean and readable code isn't just a nice to have. It's a huge thing for long-term growth. Your teammates and even future you should be able to read your code and instantly understand what's going to happen. Here is what that looks like in practice. First, use clear descriptive names. Variables, functions, classes, they should tell a story. An integer named X is a bad name, while an integer named max player score, for example, is a better name because it makes your code self-documenting and reduces the need for extra comments. Second, you keep functions small and focused. Each function should do one thing and do it well. That makes it easier to read, easier to test, and easier to debug. Third, use consistent formatting and style so that the code is easier to scan and maintain, especially in team projects. Also, write comments wisely. Don't comment what the code already says. Explain why something is done, if it's not obvious, so that others, and also future you, understand decisions and not just mechanics. And finally, also, you need to refactor often and don't let messy code pile up so that you can keep your project maintainable and prevent technical debt. The big picture is that clean code isn't just about looking neat. It reduces bugs, it makes collaboration easier, and it saves you tons of headache down the line. Alright, now the next big one, and this is something a lot of juniors overlooked. Design patterns. Honestly, if I could go back in time and give my younger self one piece of advice only in my first year, it would be this. Learn design patterns early. I'm talking about things like singleton, observer, factory, or strategy pattern. These aren't just academic theory. They are proven blueprints for solving common problems in software development. Here is why they matter. Once you learn the core design patterns, almost every single piece of code that you read starts to click. You'll see the underlying pattern and suddenly the code makes more sense. It's like having a map in your head where everything gets easier to navigate. And the benefits are huge. You'll read other people's code faster because you recognize the structure. You will communicate solutions more clearly since you're using the same vocabulary as other senior developers. You'll write better code yourself because you are building on battle-tested solutions instead of reinventing the wheel. Think of design patterns as the shared language of developers. Once you know them, you're not just coding, you're speaking the same language as the rest of the industry. Alright, and here is the last point for your first 2 years. And honestly, it might be the most important one. Learn from the people around you. Your early years aren't about proving you're the smartest person in the room. They're about building strong fundamentals, and the fastest way to do that is asking questions. A lot of juniors hold back because they don't want to look inexperienced. But here's the truth. Your senior teammates have already made the mistakes you're about to make. When you ask, why did you do this way? You're not just getting an answer. You're learning how to think like a senior developer. The biggest mistake you can make is pretending to know everything, and I have been there, nodding in meetings and then secretly Googling later. It doesn't work. What actually earns respect is admitting that you don't know and showing that you're eager to learn. This is what builds trust. So remember this, curiosity beats ego every single time. So make sure you ask plenty of questions from your senior developers and always ask for advice when you're not sure about something. So that's the roadmap for the first 2 years. Master your core language, learn algorithms and databases, write clean code and readable code, get familiar with design patterns, and most importantly, ask questions and learn from others. If you focus on those 5 things, for your first 2 years, you'll build a rock-solid foundation that will carry you through the rest of your career. Now that you've got that down, the next stage begins. Year 3 to 4. This is where you start moving beyond just writing code and begin thinking more like a true software engineer. By your 3rd year in tech, the game starts to change. You've already built some real-world experience, and now it's time for your mindset to evolve. It's no longer just about making something work. It's about making it work at scale and building systems that don't break under pressure. Early on, your question would be, how do I build an API that sends an order? By year 3, the question should shift to, how do I design this API so that it can handle 500 orders at the same time on a Black Friday? That shift in thinking is what separates a junior developer from someone already able to step into bigger responsibilities. And here is what to focus on in this stage. First of all, take ownership of projects. By now, it's not enough to just code features somebody else designed. You should be able to design your own solutions. Think how a feature should work, the trade-offs involved, and how it would fit into the larger system. And when you own a feature, own it end-to-end, which means break down the tasks, estimate the effort, and deliver with less hand-holding. This is where trust gets built and where people start seeing you and someone they can rely on. Second one is learn system design basics. This is where you start zooming out and beyond classes and methods and ask yourself, how does this service fits into the bigger picture? Start learning design system fundamentals like fault tolerance, replication, throttling, rate limiting, caching, database trade-offs. These aren't just buzzwords, they are what keeps systems alive when real-world traffic spikes. Number 3 on the list is that by year 3 or 4, it's not enough to just know your main language. You need to understand the ecosystem around it and your surrounding tech stack. That means things like CI/CD pipelines, Kubernetes, Docker, maybe Kafka, Istio. Don't just copy-paste commands from Stack Overflow. Learn why your company uses these tools and how they keep your code running in production. If you want to challenge yourself a little bit, you can also go for a certification in one of them. But the real goal is not a paper, is to actually get confident, not treating these tools as someone else's problem, but as a part of your actual skill set. Number 4 on the list is to improve your collaboration skills. At this stage, people expect more from you than just coding. You'll be reviewing PRs, mentoring juniors, and also doing KT sessions, transferring knowledge. When you are reviewing code, don't just fix syntax, point out design trade-offs or add patterns that you might see. When mentoring, focus on helping others think and not just give them the answers and the solutions straight away. And when documenting, write something so clearly that future teammates will thank you. Being a great teammate at this point is as important as being a great coder. Another one is to think about quality and reliability first. Your code working on your machine is not enough anymore. By now, you need to think in terms of production-ready code. That means unit tests, integration tests, logging, monitoring, observability in general. Start asking yourself before you code something, how will I test this? How will I know if it breaks? How will I debug it at 2 a.m. at night if something happens in production? Even if you don't go full test-driven development, the habit of thinking about quality upfront will make you a much stronger engineer. And finally, and this is a big one, build for scale, security, and resiliency. This is what separates mid-level developers from senior engineers. Start thinking about resilience patterns like retries, timeouts, and circuit breakers. Think about security like know hard code secrets, validate inputs, understand authorization and authentication, and always think about how to scale. Can this system handle peak traffic without failing over? So, years 3 and 4 about zooming out, seeing the bigger picture, understanding the surrounding stack, and thinking about scalability, security, and reliability. And here is the mistake to avoid. Don't become just a ticket closer. If all you ever do is pick up Jira tickets, code them, and move on, you'll stay stuck in your junior mode forever. To grow, you need curiosity about the systems, the architecture, and why decisions are made the way they made. This is the stage where you can stop thinking like a coder and start thinking like an engineer. Therefore, by the end of year 4, you're no longer just a junior learning the ropes or a mid-level trying to prove yourself. You've built real experience, you've learned how to think in systems, and you've started to take ownership of bigger pieces of the puzzle. And here's the thing, that sets the stage for year 5. Because year 5 isn't just a continuation of the same path. It's a turning point. It's the moment where you stop thinking only about your own code and start thinking about your impact on the team, on the system, and on the business. And that's where the shift into the senior mindset begins. Here are the big shifts you need to make in year 5 and what to focus on. Now, the first big shift you'll notice in year 5 is this. People start looking to you for guidance whether you have the title or not. Even if senior engineer isn't your job title yet, you'll find teammates asking for your opinion or following your example. And that's where real leadership shows up. Not in authority, but in influence. So communicate clearly, back up your ideas with reasoning, and lead by example. Others will follow how you work and not what you say. The second shift is about how you view problems. By this point, you should be comfortable looking at entire systems and think at system level rather than just single services. Scalability, observability, and resilience should feel like second nature. And system design principle should guide your decisions. Because at this stage, it's not just about proving your piece of code, it's about proving the entire system. And here is another shift. Realizing that your impact is no longer measured only by the code you ship. As a senior, your value multiplies when you help others succeed. By mentoring juniors, by giving thoughtful code reviews, and by unblocking teammates. Every developer you help level up expands your influence way beyond what you could achieve alone. Another sign that you're stepping up into senior territory is you stop treating code as done the moment the PR is merged and you start owning production systems. By year 5, you should feel accountable for how your code behaves in production. Setting up monitoring, configuring alerts, and debugging incidents when things go wrong is what's going to be your day-to-day job. Seniors don't just write code, they own it in the real world. Next up is about developing engineering judgment. One of the biggest markers of seniority is judgment. Knowing when to keep it simple, when to optimize, and when to push back and say no. Not every problem needs a brand new framework or some over-engineered solution. Sometimes the right answer is the simplest one. So by year 5, your experience should give you the confidence to make those calls. And finally, the danger zone of year 5, comfort. By now, you know your stack, you feel confident, and it's easy to just relax and chill and coast. But growth doesn't stop here. If you want to keep moving forward, you need to stay curious, keep learning, and don't fall into the trap of just doing tickets. The best seniors I know are the ones who never stop growing, even when they are good at what they do. And there you have it, your first 5 years in tech. From building your foundation in year 1, to thinking in systems by year 3, and finally stepping up to your senior mindset by year 5. Each stage builds on the one before it. If there is one takeaway I want you to live with, is this. Growth in tech isn't just about chasing the newest framework or adding tools on your resume or anything like that. It's about how you think, how you solve problems, and how you multiply your impact over time. The journey isn't always smooth. You'll hit frustrations, you'll make mistakes, and sometimes feel stuck. But if you focus on fundamentals, stay curious, and keep pushing yourself, you look back after 5 years and realize just how far you've come. So whether you're just starting out, if you're somewhere in the middle or close on year 5, keep this in mind. Tech isn't a sprint, it's a marathon. Your growth compounds, and the habits you build now will carry you for the rest of your career. Thanks for tuning in to the very first episode of the Tech Odyssey podcast. I am Mike, and I'll see you in the next one, where we'll keep exploring the world of tech one step at a time.